Welcome. On this video, I'm going to do 196, 197, and 198, so let's do it. This is a sneaky one. Of the following dot plots, what represents the greatest standard deviation? Now, you could assign numbers to each of these asterisks and type it in the calculator or actually calculate the standard deviation by hand, but that would take a really long time. So I'm going to go ahead and approximate this. So it looks like, notice all of them if they have symmetry. They have dots on the same side. So notice A, B, C, and D would all have the same mean if you average them together and divided by the 10 dots, which is the number 5. So the standard deviation means the typical value a number is away from the mean. So you can think of it as the average of the distance from the mean. So it's like this value is basically on the mean. This is 1 to the left. This is 1 to the right. This is 2 to the left, 2 to the right. You get the point. So it's also a measure, like range, of the spread outedness. Spread outedness. And so that's how we're really going to test is how spread out. Which one is the most spread outedness from 5? So it looks like this one's actually spread outedness from the 5. So the one that is totally the furthest away from the 5 is definitely B. All of the values are as far away from 5 as possible. So an average value looks to be about 4 away, either 4 to the left or 4 to the right. So this looks like a typical value's distance from the mean is about 4. Here it looks like a typical value's distance from the mean is about 2. Here it looks like the typical value would be maybe a little bit closer to 3, because see how a typical value here, once again, almost as much as this, but not quite. This one would be slightly up than that, and then this one would be actually probably right about there. So the one that has the furthest away from the mean, if the mean is 5, would be B. I'm going to scoot to the next question. We got a box plot, and it just happens to be laying sideways. So anytime we see a box plot, we think of a 5-number summary, and I have those 5 numbers. There's the minimum. It looks about 0. And the first bar is quarter 1. That looks around maybe 3 or 4. The median here, the middle of the box, looks to be about 10. Quarter 3 looks to be just under 20, so maybe 19. And my max before I get to my outlier looks to be around 40 or maybe 41, and then I actually have a little outlier here. So let's read the question. It says, using this data and inside a box plot, we never know how much data there is. We know there's at least 5 pieces of data. So it says, this is a picture of 374 pennies. Using this data, can we determine the interquartile range? So that's pretty cool. Okay, IQR is quarter 3 minus quarter 1. So we quantified that at around 19 and quarter 1 around 3. So I end up getting 16, and that's my answer. Again, it's this distance here. It's the distance of the inner width of the box, or the center 50% of the data is what IQR means. And so it's a really good gauge of spread outedness of the data. It's kind of like the standard deviation when the data is skewed. It's our typical value, okay, of the spread outedness. Next part of, let's take a look at, hold on, I'm gonna set the phone down for just a second. 198, another very straightforward question. I like it. 198 states a histogram, so we like it. We're back to a histogram with a frequency. A histogram shown above has a number of minutes needed by 45 students to finish playing a computer game. What is true? So now that we're back to a histogram, I see that this data is skewed. to the left. The dinosaur tail looks to be tapering off to the left. And that is our answer. Yes, indeedy do. This distribution is skewed to the left. But just taking a moment to review what we know, that means that the median is somewhere here. And that the mean, these values are pulling the mean to the left, which is why it gets its name skewed to the left. Thanks for joining us.